highlighter. This first sentence is important. Everything we've done up till now have been permutations. When we count things, the order matters. But sometimes you count something and the order doesn't matter. So the example that they have here is looking at a way a person can choose 3 books of 4. Maybe there's a grand prize, and the grand prize is you get to win 3 books. Super exciting grand prize, right? And you get to choose from 4 books that they have. So basically, you could choose book 1, 2, and 3. But choosing 1, 2, and 3, if you get to take the first 3 books home, it's not like, oh, wait a minute, I want to redecide. You put book 1, 2, and 3 down and say, I'm going to take books 3, 2, and 1 instead. And the person would look at you and say, that's identical to what you took the first time. In this situation, the order doesn't matter. So if you took book 1, 2, and 3, if the order mattered, there would be 6 of them that are all identical. Right? Picking 1, 2, and 3. No, I'm going to pick 1, 3, and 2. No, I'm going to pick 2, 11, 3. No, I'm going to pick 2, 3, and 1. Those are all the same. So in situations where the order doesn't matter, we look at the combination. So you could pick 1, 2, and 3, 1, 2, and 4, 1, 3, and 4, or 2, 3, and 4. There's only 4 options. If you have those 4 books, then it kind of makes sense. If you get to take 3 books home, you're leaving 1 behind. There's 4 books that you could leave behind. So there's going to be 4 options. Now in permutations, notice that if you had 3 objects, does it make sense that if you had 3 objects, the number of ways that you could rearrange 3 objects would be 3 factorial or 6 ways? And so what we get with a combination is you take your permutations, and just like identical objects, you have to divide out the identical objects. If in 4 things, there would normally be 4 factorial, right? Because if you had order mattered, you'd have 4 choices for the first book, 3 choices for the second, 2 for the third, would give you 24 in total. And if these are all identical, we would have to divide by 6 to get our combinations. And so the idea is that a combination is just a permutation with the order divided out as identical objects. And we have the formula on the next page. So if you think of the formula for NPR as n factorial over n minus r factorial, and that combinations is the permutations with the order divided out, we get this new formula for combinations. And unlike permutations where we hardly use the formula, the combinations formula we actually use quite a bit. So, first thing you have to decide is now, will the order matter in a question or not? If the order matters, then it's a permutation. If the order doesn't matter, then it's a combination. And you'll see some textbooks use this notation with the n over top of the r, but our notation that we're going to use is a little n, a big C, and a little r. So we're going to do some questions involving combinations. And probably one of the most famous places for combinations is in lotteries. Now, the Keno lottery, most people don't really know about, but I'll use, after we do this one, I'll do like a famous Canadian lottery. Have you ever heard of Lotto 649?
Yeah.
Okay, that's a famous Canadian one. I'll explain how that lottery works, but we'll do the Keno one first. In the Keno lottery, you've got 80 numbers to choose from. If you pick the right 20 numbers, and it doesn't have to be in the right order, then you win the super big prize. So the way we set this up with combinations is, so we're going to use the formula a lot. You have 80 things you need to choose, so I sort of think of the C in combinations as choose where the order doesn't matter. 80, choose 20 of them. And if we go to our formula, this is the other nice thing about the combinations formula, is that the 80 factorial is on the top, the 20 will be 20 factorial on the bottom, and there's another factorial on the bottom, and the other number is such that the bottom two numbers always add up to the one at the top. So it's really easy to write out the combinations formula because it has that nice pattern built into it. 80 factorial over 20 factorial, 60 factorial. This is a huge number. If I type it in my calculator, 3.54 times 10 to the 18. And depending on how you type it into your calculator, you might actually get errors in your calculator. We'll just double check here. If you do 80 and then hit the math button and go over to probability and choose 20, the answer appears. But if you decided to do 80 factorial first, figure out what that is, it's too big for your calculator. Your calculator explodes. It's like, that's too many numbers for me to remember. But it does allow you to do the 80 choose 20. And it's a very huge number. So you're going to have to find where your C button is on your calculator. Now, I said, wow, did they write a big 6 and a little 49? Is that how it's advertised? I think it looks like that. Lotto 649 is very similar to the Keno lottery, but not as intense. In Lotto 649, there are 49 numbers, and you just have to choose 6 of them. If you choose all 6, the order doesn't matter, right? You win the grand prize. And sometimes they have like advertisements like $35 million, $45 million. That's pretty exciting. So what we're going to find out right now is the number of different ones you could find is 49 choose 6. In fact, we can figure out the probability of us winning the lottery. You take 6 numbers. 49 choose 6, if we go to our calculator and type that in. 49 math choose 6. Okay? Now, we have to think about this number because that's a big number, 13,983,000. I'm going to take a deck of cards, okay? Oh, here we go. How many cards are in a deck of cards? 52, right? So, if France randomly picks one.
Ace of spades. Oh, ace of diamonds, that's close.
You were close, right? If he had got ace of spades, everybody would have went, whoa, and been super amazed. His chances of doing that were 1 out of 52, and you would have been amazed. Okay? Winning the lottery, for Lotto 649, is 1 in 13 million. Now imagine, I now get a new deck of cards with 13.9 million cards in there. Okay, what card number did I pick?
4 spades.
Oh no, they're all numbered from all the way up to 14 million. You have to tell me the number I picked in my head. 12? No, I picked 123,123. How hard would it be to pick that? Almost impossible. Okay? You want to know about how impossible it is. Now, I don't want you to do this at home because you might drive yourself crazy, and I don't want any of you to go crazy before the end of the year. But if you flip a coin, you get heads or tails. Ooh, I got heads. Now, is it possible I could get heads again? Yeah, it is possible. I didn't. Okay, it is 10. There, it's heads again. If you wanted to get heads 10 times in a row, would that be impossible? No. Mathematically, how many ways can that happen? We'd have first time, 2 choices, second time, 2 choices. Does it make sense that 10 times It's only 1,024. So technically, you could try 1,024 times, and probably you would get 10 heads in a row once. Okay? You want to win the lottery? Before you play the lottery, first go home and flip a coin. Is 21 enough? No. How about 22? Not quite. How about 23? Not quite. 24 is already too much. So flip a coin. Once you get 23s and heads in a row, then go out and buy your lottery ticket. Otherwise, chances of winning the lottery is so small that it's basically nothing.
For the music video that happened on the fundraiser,
Yeah.
for Glen Public Grill, they have this game where they flip the coin and the last one standing, they have to choose their judge skills.
Okay.
And the last one standing is to win a prize or
Yeah.
something, and it can go for like 15 rounds.
Yeah.
If you have the option, you have to sit down.
Yeah.
And it's like the whole
Like that, same idea. So you'd have to guess it right that many times in a row. But, so, playing the lottery, if you're playing the lottery because you are planning on winning, I'm going to tell you something, that's not a good strategy. Your chances of winning are basically nothing, but yet people win. Why do people win if it's so little? Well, eventually, almost all the ticket numbers get bought. Right? It's not guaranteed. If I sell 14 million tickets, it's not guaranteed that everybody picked a different number. Some people could pick the same number, right? But if you have a lot of people playing, chances start to become more probable that one of those numbers will get picked. But when nobody's number gets picked, the next week the lottery is just big. So, how much does it cost? Does anyone know? Is it $2 now?
How much is it?
$2?
For the $6.49,
Yeah.
it's $4
$4 to play?
with the extra.
Okay, without the extra, just
It's
playing
$3.
$3. Okay, so we can take this number, okay? This is my plan. This is my plan. Tell me if you think it's a good plan. We'll go up to the number again. There it is. Times $3. Okay? 41,951,440. So
Sometimes it gets bigger.
we wait. We wait until it's $50 million. Then we go to the bank and say, I'd like to borrow some money. And the bank says, oh, okay, how much would you like to borrow? I would like to borrow $41,951,448. And they'd be like, you'd probably say no. But maybe you get someone like, what would you like to do with that money that you want to bring? I'm going to win the lottery. Because if you bought all 13,983,816 tickets, you would guarantee yourself to win the lottery. Just take a little while to fill them all up.
I think it's against the TOS, because I think there's a guy in the state too. He's like a millionaire, he just bought every single ticket and take like chance and then made much.
You could, right? What's the only thing that could go wrong? Right? We borrowed $41 million, right? The grand prize is $50 million. Someone else wins with it. That's just a little problem, right? Because then your share is $25 million. You go back to the bank and you're like, I got good news and bad news. I won the lottery. But unfortunately, I had to share it with somebody else. So, you know how you borrowed me $41 million? I've only got $25 million. So, probably their risk tolerance wouldn't be very good. But technically, if it's on your bucket list to win the lottery, you could do it. You just need to save up a lot of money first. Then you could buy every single ticket. And if no one shares with you, you're going to make money. I'd just be really nervous that day and then you'd have to go and be like, oh crap, where did I put ticket number 759,382? You have to search through them all to find the winning ticket. Could be a little bit annoying there, but that's the idea. Now, with the lottery, Okay? With the lottery, so knowing that your chances are so little, you are theoretically, when you pay the $3, throwing that $3 away. However, if you think that that $3, because you can't win unless you play, right? So if the $3 gives you the best daydream, like you got one whole day where you imagine you just bought the winning ticket, that's such a good feeling, and the next day you lose, but that's okay. During that day, if that daydream is good, then your $3 is well spent. Yes.
Is your microphone still not?
Oh, it's all dead. There we go. So that whole story is going to be not on there, but whatever. It'll be on the next one. And in fact, what I think in England they changed it. They have also had Lotto 649, but they changed it to Lotto 659. So now your chances of winning are even worse. However, if you even got 2 numbers right, you won a free ticket to the next one. So then, they said, if, when you pay your $3, if you're really paying for that daydream, then the Lotto 659, which has bigger prizes, so you have a better daydream than before. And if you win a free ticket, your daydream gets to last for longer. Maybe it's even better, even though your odds of winning are less. Right? Now, I'll tell you a secret.
Hi, could I please have Sophia to the office?
Yeah, she'll be right down.
Thank you.
I guess I don't have to tell my secrets on video. I can end it. Oh, I'll give you questions for this one, then I'll tell you my other story. 4, 5, and 7.